All right, let's start with an intro to organic chemistry. We're going to start by going over a few things that you need to remember from Chem 20. Don't freak out if that's been a while. Like I said, we'll cover everything that you need to know. So even if that's been a long time since you took Chem 20, you'll be fine. So in your notes, we're going to start with this first page is basically just Chem 20 review, and then we'll start into some new material on the next page. But the first thing here at the top is how to draw Lewis and structural formulas. So let's just jump over here really quick as a reminder. Remember that Lewis structures draw all of the electrons that hold something together. So if we were drawing something like, let's say water, for example, H2O, we know that we would have an H and an O and an H. I know that the electrons, there would have to be at least one pair holding those together. And then if you remember back doing this stuff in Chem 20, we would take the rest of the electrons and first try to fill up the outside, which in this case is 2 hydrogens, so they're already full. And the rest of the electrons we would put around the central atom. So in this case, this is what we would end up with. We'd have 8 total electrons, 2 in between the oxygen and the hydrogen in each case. That's what we would call our Lewis structure. Our structural diagram then would look like, instead of showing all the electrons, just showing the bonds. So we would have an O with a single bond to 2 hydrogen atoms like that. Okay, that's Lewis and structural, I should write that in, diagrams. Now you need to understand the Lewis structure to help you with a lot of the stuff that we're going to do, but we very rarely draw the Lewis structure. And I'll show you why here in just a second. We can take a shortcut to get to the structural, but you do need to still understand the Lewis structure because that's going to become a little more important when we get into the reactions a little bit later on. But if we jump back to the notes here, and this is how you can shortcut this, the honk rule. So each hydrogen atom wants to form one bond, and in Chem 30, hydrogen will only ever form one bond. That's always the case. Each oxygen wants to form 2 bonds. Each nitrogen, which we don't really deal with, is going to form 3, but you won't have to worry about it. And every carbon will always form 4. Now these are not hard fast rules for always, but they are hard fast rules for organic chemistry. So in this unit, in Chem 30, you will never break these rules. Hydrogen will always form 1, and that's the honk. So each H is 1, O is 2, N is 3, C is 4, and they will always be that way. So that means we can drop down to these other examples, and let me just switch over to that screen here for a second. And we can draw, let me scroll that up a little bit actually too, so we can draw on here. If I know that carbon always forms 4 bonds and hydrogen always forms 1, remember from Chem 20, that the molecule that can bond more, or the atom I should say, that has a higher bonding capacity always goes in the center. So in this case I know that carbon is in the middle, and the H's must be around it like that. So every carbon, so the carbon here has 4 bonds, all of the hydrogens have 1, everybody's happy. Similar on this one, I know nitrogen forms 3, so it goes in the middle, and the 3 H's will go around it that way. Okay, next one's a little bit trickier, but not too bad. I know that carbon still wants to form 4 bonds. So in this case, those 3 H's will go there, and then there's an O, and then there's an H. So if we check, carbon has 4 bonds, every hydrogen has 1, and the oxygen has 2. So we're doing okay. Same thing for the next one, we've just added in a second carbon. So I have 2 carbons now with 5 H's, like that, and then an O that's attached to the H. And again, you could check your honk rules. Everything here would work out just fine. Every carbon has 4 bonds, every oxygen has 2, and every hydrogen has 1. So keep that in mind. That's going to help you out a ton going forward. Don't worry too much about Lewis structure, but if you're feeling fuzzy on that, let me know, because you do need to understand the theory of the Lewis, how it compares to the structural diagram, like I said, for later when we get into the reaction stuff. So it's better if we touch that up now. So if you're having any trouble, let me know.